In this video we're going to see how to graph a line and how to write the equation of a line from its graph. So first let's start with the graph of the line as seen on the screen, the blue line, and if we wanted to write the equation of that line, there are two things we need to know. First of all, we want to see what the slope of that line is, and then we want to see what what's called the y-intercept is. Well, those two things are fairly obvious. The slope of the line is sometimes defined as, I'll write it down here, m represents slope, it's the abbreviation for slope. Sometimes it's defined as the rise or the run. Now what that means is if you pick any 2 points on the line, for example that one and that one, the rise is the vertical distance between those 2 points. So we just count up from there to there. So the rise is 3 units. The run is the horizontal distance, and that would be from there to there. So the run is 1 unit. Therefore, the slope of that line is 3. The rise over the run. Sometimes also known as the change in y over the change in x. The little triangle represents delta, which means change. So the change in the y coordinates between those 2 points over the change of the x coordinates between those 2 points. Alright, now that we know the slope is 3, the next thing we need is what's called the y-intercept, and that is simply where the line is crossing the y-axis. Well, we all know the x is the horizontal axis, the y is the vertical axis, and this line is crossing at -1. So the letter used to represent that is the letter B, which represents the y-intercept. So the y-intercept is -1. Now we can write the equation. The equation of any line can be put in the form of y equals mx plus b. Now this is called the slope-intercept form because all you have to do is fill in the value of the slope and the value of the intercept. So the equation becomes y equals 3x plus -1, or simply -1. So y equals 3x minus 1 is the equation of that blue line. Now what that means is any point on that line, if you plug it into the equation, it'll make a true statement. So we could pick this point down here, which is the point -1, -4. Alright, now if we take that point and plug it into the equation, as you can see here, I put -1 in for x, I put -4 in for y, and that makes a true statement because -4 is equal to 3 times -1 minus 1. Now let's take a look at a couple special lines. I'll scroll down to the next frame. Notice the red line and the purple line. The red line is a horizontal line and the purple line is a vertical line. Now we can use y equals mx plus b again to figure out the equation of, in particular, the red line. Remember, m is the slope. All you have to do is take any 2 points on the line, which I'm highlighting right now. The slope is the rise over the run. Well, the rise is none. There is no rise between the 2 points, so the rise would be 0 and the run would be 1, and 0 over 1 is 0. So the slope of the red line is equal to 0. Now remember, the only other point you need is the y-intercept, and you can clearly see that the y-intercept is 2. Therefore the line would be y equals 0x plus 2, or in other words y equals 2. Now in general, any horizontal line will just be in the form of y equals b. So wherever the y-intercept is, that will be the equation of the line. Y equals 2 in this case, or if it were passing through, let me quickly sketch this green line. If it were passing through the point down below the origin, which is -1, the equation would be y equals -1. Now the other special case is a vertical line like the purple one. Now in that case, when you try to determine the slope of that purple line, since the line is vertical, going straight up and down. It's kind of a little tricky situation because the slope, the rise is 1, but the run is 0. There is no horizontal change between the points. And 1 over 0 is undefined as a fraction. So in other words, we'll say that line has no slope. So any line that is vertical will be an equation in the form of x equals whatever point that the line is passing through, whatever x coordinate. Well, if you look at the line 1, 2, 3, 4, it's passing through x equals 4, so the equation is x equals 4. So you should know that any horizontal line will be y equals whatever the y-intercept is, and any vertical line will be x equals whatever point that the line is passing through. The next thing you'll want to be able to do is write the equation of a line without the graph of a line, but just with some information about that line. For example, our first problem we'll look at is if we're given the slope of a line is 1/3 and the intercept is -2, this is a real easy process to write the equation of a line because we all know that the slope, once it's given and once the intercept's given, all you have to use is the slope-intercept form, y equals mx plus b, and sub in. So for m, we put in the slope of 1/3, and for b, you put in -2. And there's the equation of the line. Now sometimes the equations of lines are written in different forms. Another form called standard form is ax plus by equals c. So you would just take the equation we came up with and rearrange things a little bit. I'm going to take the 1/3 x to the left by subtraction, leave the y where it is, leave the -2 where it is. And then you could multiply through by -3 and end up with a positive coefficient on the x, and y becomes -3 because I'm multiplying everything by -3, and -2 becomes 6. So this is the equation of the same line as this one. It's just in a different form. It's called standard form versus the yellow highlighted one is slope-intercept form. Let's take a look at a different example, number 2. Let's say we're given a slope of -4. This time I'll just use the abbreviation m. m equals -4. And we're going to be given a point 2, -3. So we know this point 2, -3 lies on the line, and now we want to find the equation of the line. Let me scroll here a little bit so we get some more room. Well, we start with y equals mx plus b, our slope-intercept form. Let me stick the x in there and sub in again. So y equals -4x plus b. But whoa, not this time. We don't have a b. So what you do in order to find b is you also sub in 2 and -3 for x and y. Because given two coordinates, 2, -3, the first one is your x coordinate, the second one is your y coordinate, and that point lies on the line. So we're just going to sub in. For y, we put in -3, and for x, we'll put in 2. Now this time we're going to manipulate the equation and solve for b. So -3 equals -8 plus b. Add -8, or add +8 rather, to both sides, and we get 5 equals b. Now we know the intercept is 5. We go back to the standard form of the slope-intercept, y equals mx plus b, and now we'll sub everything in that we know. Y equals m. M is still -4 as it was in the beginning, and b is now determined to be 5. There's the equation in slope-intercept form. Again, you can manipulate that and put it in a different form if you so desired or were supposed to. Let's take a look at one more example, referring to part C here, where you're given 2 points on a line. So let's take the scenario. We know a point on the line is 1, -4, and another point on the line we'll take as 2, 2. Alright, so this time we don't know m and we don't know b. So we go to the slope formula, whereas slope is the change in the y, or y2 minus y1, over the change in the x, which is x2 minus x1. Again, that's rise over run, or the delta y over delta x. They're all the same thing. So in order to determine the slope, we subtract the y coordinates let me switch to red here. So there's y2 and there is y1. So we subtract y2, subtract y1. Careful with the signs. And then x2, x1. So x2 is 2, x1 is 1. We do the math, and we get 6 over 1, which is 6. So now we know the slope is 6. Now you kind of do it exactly like we did problem number 2. So we go back to our slope-intercept form, y equals mx plus b. And for y, you can choose either y. Originally we were given two sets of points, 1 comma negative 4 and 2 comma 2. I'll just go with the first one. So y I'm going to replace with the negative 4. M we found to be 6. X, if we're going to use the negative 4, the first set of coordinates, you have to use the first x also. So we'll plug in 1 for x. Again, we're going to take this little equation and solve for b. 6 times 1 is 6. We subtract that over to the other side and get negative 10 for b. And now we have all the necessary information. Y equals mx plus b. Let me fill in y equals m, which we determined to be 6, x plus b minus 10. And there is our equation in slope-intercept form. We'll just quickly put that in standard form. Take the 6x to the other side, be negative 6x. Leave the y where it is, equals negative 10. Now that's a viable answer, but usually the lead coefficient, which means the first number in front of the x, is positive, so you could just take that equation, multiply everything by negative 1, and end up with 6x minus y equals positive 10. So all three of those answers are really the same. It's the same line, but it's just determined by what you're asked for, whichever form you want to give. If you want it in slope-intercept form, we go with this one. If you want it in standard form, we go with that one. Alright, that's about all the things you need to know as far as finding the equation of a line and being able to graph a line from the slope and the intercept.